In this section, we'll review Pythagorean theorem and have an intro into our trig unit. Example 1, you have a spot on your shelf for a TV. The spot has a length of 28 inches and a height of 16 inches. When you go to the store, what size TV should you look at purchasing? And note, TVs are sold by their diagonal length. So when you go to the store and you buy like a 50-inch TV, they're talking about the length of the diagonal. So what we need to figure out is, with these dimensions, the 28 by the 16, what's the length of the diagonal of the TV that could fit in our shelf? So again, here's our shelf right here, and we want the diagonal length, so we'll know what kind of TV to look for. And we know that the length of the spot is 28 inches, and the height is 16. And this is a right triangle that we're looking at right here. And if you remember from geometry, if we have a right triangle and you have two sides of a right triangle, you can use something called Pythagorean theorem to solve. And Pythagorean theorem is a squared plus b squared equals c squared. And that is when you have a right triangle. The legs are the two shorter sides that are connected to the 90. So one of our legs is A, the other is B. In this triangle, we have A and B as well. So the legs are connected to the 90, and the hypotenuse is the longest side, which is across from the 90-degree angle, and we call that side C. So let's plug in. We have the two legs here, the 16 plus the 28. So we have 16 squared plus 28 squared equals, and we want the hypotenuse, the diagonal length, so I'll say C squared. So there's Pythagorean theorem. And then we'll solve. I'll do 16 squared plus 28 squared. I'm going to add those together. And we'll get 1,040 equals c squared. And we just want c. We want to get rid of the squared. To get rid of a squared, we're going to square root each side. So if I take the square root of our answer, we will get about a 32.249. So that's the length of the opening. So you would have to get a 32-inch TV or less to fit into that opening if you're going to look at TVs. So 32-inch TV or less to fill in that spot on the shelf. So again, our goal today is we'll be reviewing this Pythagorean theorem, solving for a missing side if you're given two sides of a right triangle, and then we'll start taking a look at our intro to trig. So here's our next example. You lean a 10-foot ladder so that its base is 1 foot away from the base of the wall. How high up the wall does the ladder go? Okay, so here's my wall, and we'll make my ladder here. Ooh, the ladder's only 1 foot away from the wall. Okay, so here's my right triangle. So it's 1 foot away from the wall. The ladder is 10 feet. And we want to figure out this distance. How far up the wall does the ladder go? Right here. Okay, so again, we have a right triangle and two sides of a right triangle, so we can use Pythagorean theorem to solve. A squared plus b squared equals c squared. And here the legs are going to be the 1 foot, and then this length right here, A or B, the other leg. So we'll have 1 squared plus b squared equals our hypotenuse, and here the longest side is the ladder, it's 10 feet. And we'll square that. And so that's what it looks like when we plug into Pythagorean theorem. And we have 1 plus b squared equals 100. We'll subtract 1 from each side as we're solving algebraically. So we have b squared equals 99. And then to get rid of a squared, we will take the square root. And so I'll type that into my calculator. The square root of 99 is about 9.9. 9.5 if I round, feet. So that ladder goes up 9.9 feet up the wall. So we can use Pythagorean theorem to solve for a leg or a hypotenuse like we did for the warm-up. And so if you have a leg that you're solving for and some numbers on one side, you're going to algebraically solve to get the leg by itself. So let's do one more example. You're building a skateboard ramp that you want, pick a different color here, that you want to have a height of 3 feet and a length of 4 feet. How long is the slanted part of your diagonal? of your ramp. Okay, so here's our ramp. The height is 3 feet. The length of, and I guess I should have specified in this problem, the horizontal length is 4 feet. How long will that diagonal part be of our ramp right here? So that is the hypotenuse, we'll call it C. All right, we'll plug into Pythagorean theorem, a squared plus b squared equals c squared. This time we have the two legs, so we'll plug in 3 squared plus 4 squared equals c squared. And in this case, we can get 3 squared, which is 9, and 4 squared, which is 16, and get 25. Whoops. 25 equals c squared. And again, to get rid of a squared, we're going to square root each side. So here c is 5. So that length of the ramp will be 5 feet long. So we've looked at using Pythagorean theorem to solve for a leg or the hypotenuse, so you should be comfortable doing both. Let's take a look at the next problem. Can we use Pythagorean theorem to find x in this triangle? Why or why not? So if you notice, we have one leg, we don't have another leg, and we don't have the hypotenuse. So if we try to use Pythagorean theorem, we don't have enough information. So no, we can't use Pythagorean theorem. So no to Pythag. There's not enough information. Okay, and so if there's not enough information, we have this other method that we're going to use to solve, and it's called trig. It's right triangle trig that we're going to be looking at. Now, in order to use right triangle trig, we have to first know like how it works. We're going to be taking a look at these ratios, and we have to know how to set up these ratios. And then later this week, we'll take a look at, okay, now that we know how to set up the ratios, we can solve for a missing side of a triangle, and we can also solve for a missing angle. And so I'm going to be using these words today. One is reference angle. It's the angle that we're looking at. So we're going to choose an angle that's not a 90-degree angle. So there's two angles in here I could choose. And then we have the hypotenuse, the longest side of the triangle. We have the adjacent side, which adjacent means right next to or neighboring the adjacent, the reference angle, so next to. And then we have the opposite, which means it's the side that's across from our reference angle. So adjacent, next to, opposite, across. All right, so how does trig work? It all deals with ratios of sides of similar triangles. So what I mean by that is I have three triangles right here. They're similar. The corresponding angles are congruent. The sides are different. So we're going to take a look at what's true about the ratios of the sides. So it says using the 50-degree angle as the reference angle, find the lengths of the opposite side and the hypotenuse for each triangle, and then divide. We're going to find the ratio by dividing. So here's our reference angle. The opposite side is across from the angle. The hypotenuse is the longest side. So again, here's our reference angle, here's the opposite side, here's the hypotenuse. Here's our other reference angle, here's the opposite side, here's the hypotenuse. So we're just going to fill in this table on Desmos, so you'll be able to type them in. So in the blue triangle, the opposite side is 3.74, the hypotenuse is 4.9. So we're going to divide out 3.74 divided by 4.9. We'll do the same thing for the orange triangle. In the orange triangle, the opposite side is 4.58, hypotenuse 5.97. Let's divide them, 4.58 divided by 5.97. And I'll get those decimals at the end. Let me write up the last ratio. So in our green triangle, the opposite side is 7.45. The opposite hypotenuse is 9.67. And again, we'll take our opposite side divided by our hypotenuse. And let's get those answers. Okay, so first blue, we'll get the approximate answer. So if I divide that out, I'll take my calculator, take 3.74 divided by 4.9. I get about 0.763265. Let's do the same for the orange. 4.58 divided by 5.97. It's about 0.767169, and then let's do our green triangle. We'll take 7.45 divided by 9.67, and it's about 0.770424. What do you notice about these ratios? They're very similar. So they're very close, they're pretty much the same number that we get for that ratio. So ratios, just when we're dividing a side by another side, and it doesn't matter, like if the angles are a certain angle, then it doesn't matter what the sides are, we'll get the same ratio. And those ratios compose this idea of using trig to solve for sides and angles. So our goal today is, can we set up the trig ratios to solve? Okay, so these trig ratios, and again, these trig ratios are built into our calculator so that we can use them to solve. One is called sine, one is called cosine, and one is called tangent. And how we set it up is we choose our angle. It's either it's one of the non-right angles. So here, either angle A or C. And we're going to label our sides, and that's what we'll practice today, labeling the sides. And then we're going to practice setting up our ratios, which if it's sine of A, it's opposite over hypotenuse, the cosine of A is adjacent over hypotenuse, and the tangent of A is opposite over adjacent. And so to help us remember how to set it up, there's this acronym SOHCAHTOA. And so that's what we're going to be using to solve. All right, so here's our goal today. Can we find the reference angle, label our sides, and set up the ratios? And then we'll start solving later this week. So first one, let's use A as the reference angle. So there's our angle. Let's label the sides in accordance to that reference angle. So I like to start with the hypotenuse. It's the longest side. I should put in my 90-degree angle here. So here the hypotenuse is 5. The adjacent side is the side that's also next to our angle that's not the longest side. So here our adjacent side is right here. It's the 4. It's next to the angle. Again, the hypotenuse is also next to the angle, but it's longer. So it's the shorter side that's next to our angle. And then the opposite side is across from the angle. So here 3 is our opposite side. Okay, so we've labeled our sides. O, A, and H is what I like to label them. So again, I'll relabel them. So I have the H, and here's the adjacent side, and here's the opposite side. And now we're going to write our 3 trig ratios. So sine of A is the angle, is opposite over hypotenuse. So the opposite side is 3, the hypotenuse is 5. If we could reduce the fraction, we would, but 3/5 is already in lowest terms. Let's do cosine of A. Cosine is adjacent over hypotenuse, and the adjacent side is 4, the hypotenuse is 5, so that's 4 over 5. And then the tangent is opposite over adjacent, and our opposite side is 3, our adjacent side is 4, and again, if we could reduce the fraction, we would. So that's our goal today, is just, can we set up the ratio? That's what it looks like. Let's try the next one. Let's change our reference angle to C. And let's label our side. The hypotenuse is still the 5, but now the opposite side is the 4. It's across from the angle C, so here's our opposite side. And the adjacent side is the 3, which again is next to, adjacent means next to our reference angle. All right, so again, let's use SOHCAHTOA, so I'll write it right here, SOHCAHTOA, and let's set up our trig ratio. So sine is opposite over hypotenuse, so sine of C will be 4 over 5. The cosine of C is cosine's adjacent over hypotenuse. The adjacent side is 3, hypotenuse is 5, and tangent is opposite over adjacent. The opposite side is 4, and the adjacent side is 3. So it's just, can you choose your angle, one of the non-right angles, label your side. The hypotenuse is always the longest side, and then you have your opposite and adjacent sides, and then using SOHCAHTOA to set up the ratio. Okay. Let's try one more example, and this will be what you practice today. There's some Pythagorean theorem and some setting up your trig ratios. Again, this is now angle A right here. So again, label our sides. We have the hypotenuse, we have the opposite and the adjacent side, we have our SOHCAHTOA. Sorry, my H is messy here. All right, so sine is opposite over adjacent. Let's change colors here. All right, so opposite is 10. No, opposite over hypotenuse, I'm sorry. So opposite over hypotenuse, and hypotenuse is 26. Ooh, we have to reduce that. They're both even numbers, so I can divide each by 2, and we'll get 5 over 13. So there's the ratio that we want. Oops, I forgot my, okay. So 5 over 13, I can write that better. Cosine is adjacent over hypotenuse. The adjacent side is 24, the hypotenuse is 26. Again, reduce it, so I can divide each side by 2 and get 12 over 13. And then tangent is opposite over adjacent. The opposite side is 10, the adjacent side is 24, and reduce that, so we'll get 5 over 12. So the lesson today is Well, the assignment today, the link is on Google Classroom. It's a quizzes. So you're going to be matching up these trig ratios, and then also you're going to practice using Pythagorean theorem to solve for missing sides of a right triangle.